Hey scholars, it's Miss Marnon. So yesterday you worked on markups. Today we're going to do markdowns. So they're going to be similar to percent decrease. So that's going to go back to thinking about that Syracuse stray cats problem that we did when we did our percent increase and percent decrease lesson. So our objective today is to solve problems with percent markdowns. So first we have a review question. Mrs. Zahn is selling Avid supplies. She purchases a box of binders for $29.99 and marks up the price by 30%. How much will Ms. Zahn sell the binders for? So pause the video and see if you can answer this review question on your own. Okay, so you should have the original price as your whole. We're going to mark it up by 30%. That's the markup rate. And we do know there are two ways to solve these problems. So we could either do find the markup and add it on at the end, or just do 100 plus the markup rate and do it all in one step, the lazy math way. So I'm going to do it the lazy math way. So quantity equals percent times whole. I want to find what the selling price is. My percent, I'm going to use 100 plus the markup rate. So I'm going to use 130% times the whole, which is $29.99. So this is going to tell me all in one step what the selling price is. So if we're using the yellow calculators at school, you can do 130% times it using the percent key. If you're using Desmos, you can do 130% of $29.99 or change it to the decimal 1.3 times $29.99. No matter which way you do it, you should get a selling price of $38.99. So that's just a review of doing markups from yesterday. For our preview, Mr. Jordan is ordering pizza for his students. He has a coupon for 10% off his purchase. Draw a tape diagram that represents this situation. So we just want to make sure that we can see what percents off mean. So if I was going to break this up into chunks of 10%, I know this whole diagram represents 100%. 100 divided by 10, I'm going to have 10 pieces. The easiest way to do 10 pieces is to first split it in half and then split the half into 5 pieces by drawing 4 lines. So there's 1, 2, 3, 4. Those are my 5 pieces here. 1, 2, 3, 4, and those are my 5 pieces here. We want them to look as equal as possible. So now if it's 10% off, that's really getting rid of this box right there. So what we would be left with is 90%. So if we knew what his total order was, so if Mr. Jordan ends up ordering a bunch of pizza, we figure out what it is, we would have been able to split this up into these 10 boxes, subtract the 1 box, and that would have told us the total price. But it's important to see that if we wanted to what that actual price was after the markdown or after his discount, it was 90% of it. So how those 12 cats in our percent increase and decrease lesson was 70%, not the 30% in the problem. So that's the connection we need to make with this preview. Let's look at some of our vocabulary. So now we're going to do markdown. So it's just the amount of decrease. And it's usually in dollars. So instead of going down by number of cats like we did in that cat population problem, now we're going down in dollars. And it's just another word for discount. So you guys know discounts and sales pretty well. That's all markdowns are, discounts and sales. So the markdown rate is going to be the actual decrease in price. And it's going to be in a percent. So if we want to look at the selling price, it's going to be the original price minus the markdown. So we're not going to add it this time. This time we're going to subtract it and get a lower number. We want to earn money or save money, so we're going to spend less. So let's talk about what the quantity would be for this. So for us, the quantity, if we're talking about just a markdown, the quantity is the markdown. So how much it went down. Our percent is going to be the markdown rate. And our whole is going to be the original price. So whatever it was originally selling for before the markdown. So let's insert a new row. Let's talk about, so if maybe instead of just figuring out how much it went down, so if we did like for the preview question, the 10%, if we did 10% of whatever he sold or whatever he bought, that would be the amount marked down. But if I just want to know how much he's actually spending, that 90%, our quantity is going to be the sale price or the new selling price. For our percent, instead of just the markdown rate, we're going to start with that 100%, and then we're going to subtract out the markdown rate. And our whole is still going to be our original price. So instead of adding it on for our lazy math way to get right to the sale price, we're going to subtract the markdown from 100%. So this is something that we should be referencing whenever we're not sure which one's the quantity, which one's the whole. So let's look at some examples. Karen went shopping and purchases a set of bracelets for 25% off the regular price. So 25% off. I'm going to box sort off because it's going to tell me that's what we're getting rid of. The bracelets originally cost $44. This original is telling me this is the whole. We want to know what is the sale price. So just like with markdowns, there are two ways we can do it. So I'm going to show you both ways. So we have path 1 and path 2. So let's do path 1 first. So the first solution pathway, we're going to figure out what that markdown amount is and then subtract it. So we're going to set up quantity equals percent times whole. So in this case, our quantity is the markdown. That's what we're going to try to find. Our percent is going to just be this 25% off times our whole is the 44 from the problem. So if you have the yellow calculator where you can just do the percent key, you can just multiply this out or change this to the decimal 0.25. See what you guys get on your calculator. I got 11. So that's the amount that it was marked down. So what I need to do is take this original price and subtract away that markdown. So the sale price of these bracelets is $33. So that's path 1 that you can do. The other path, so I'm going to call it path 2, that's my lazy mathematician way. I like to do things in one step. I see that we can do this all in one step by using the sale price and then 100 minus the markdown rate. So let's start setting up quantity equals percent times whole. And for the quantity, this is what we're going to find, but it's going to tell us the sale price right away. Our percent, we're going to do 100 minus this 25%. So I'm going to use 75% times the whole, which is 44. So now we can do 75% times 44. Or change it to a decimal, 0.75 times 44. And right away, it's going to tell us our answer as $33. So it's just one less step. So like I said, mathematicians are kind of lazy. We like to find the easy ways, do it in one step instead of two. But if the first way makes the most sense to you, do it the first way. It doesn't matter. It's just one step, it's subtracting. All you're doing is extra. But it's not really going to make a difference. No matter which way we do it, we get $33. So let's look at exercise 2. A car that normally sells for $20,000 is on sale for $16,000. What percent of the original price is the sale price? So this original price is our whole. The sale price is our quantity. They just want to know what percent is that of that. So this is just going back to our basic quantity equals percent times whole. We don't even really need to think about which is what. So we're just going to have our quantity as 16,000. Our percent is our mystery times our whole is 20,000. So pause the video and see what you get for this. What percent is of the original price is the sale price? Okay, so if I am going to divide all of these out, so divide by 20,000, 1, 2, 3 zeros, 20, 1, 2, 3 zeros. This is going to go away. We're left with X on this side, and then we're going to get the decimal 0.75. To change that to a percent, move the decimal over or multiply by 100. 75%. So the sale price is 75% of the original price. Now it's saying, what is the discount rate? So if we know that the sale price is 75% of the original price, which is 100%, we know that how much they took off from 100% is 25. So what we're saying is we're starting with 100%. How much if we take away that 75%? 25% is what they ended up taking away from the original price. So exercise 3 is kind of similar to what we did yesterday, where we looked at these things in a table. So it wants us to calculate the markdown rate for each of these. So what we can do is we can do it the same way here, where you could divide them out and then subtract from 100, or you could find the difference between the prices, and that's going to be the markdown rate. There's a lot of different ways to do this, so why don't you pause the video and see if you can determine what the markdown rate is for each of these rows. So I think the easiest way to do it would just be to divide them. So divide the selling price by the original price. That's what we did here, is we divided the selling price. So this one would be P divided by D to get that kind of percent, and then we could just subtract it from 100. So you could do this all on your calculator. I got 0.8 or 80% the entire way down. So if when I divide it, I got 80%, so that means the selling price is 80% of the original price. How much that was taken away was 20%. Oh, my pen's being silly. So, and that's going to be for all of them. I'm not going to write it on each row again, but the markdown rate for all of those rows is 20%. If this is something that's still confusing you, make sure you ask about it in class, how we did this. So is the relationship between the original price and the selling price a proportional relationship? Justify your answer. This sounds like a CER to me. So it's always going to come back to proportional relationships. We have them everywhere in 7th grade math and even beyond. So is this proportional? What's our claim? So my claim is yes. I see that I got these 0.8s all the way down. So yes, it is proportional. Our evidence in my work, we found a constant unit rate, right? It's always 80% or 0.8. So we found a constant unit rate of 0.8 or 80%. We know that proportional relationships have a constant unit rate. Quick, easy math CER. Yes, it is proportional. In my work, proportional relationships have a constant unit rate. When we are done with all of this, you guys have 3 practice problems. You only need to pick 2 again. The third one, again, might be a little bit more of a challenge than number 1 and 2. And then you have an exit ticket. Can Miss Figueroa use her gift card to buy that laptop, or is it not on sale enough? When you're done, you're going to go to Canvas and complete independent practice 23.